Hi friends, welcome to the channel Tech EE. Hi friends, now we are going to discuss about the bridge rectifier. In the full wave rectifier there is having only two diodes. Full wave rectifier it is having only two diodes. For the bridge rectifier we are having four diodes. In most of the applications we are using bridge rectifiers only. Coming to the concept, the bridge rectifier. In this bridge rectifier it is having only one secondary transformer and four diodes. Here the bridge rectifier, the operation it seems like as same as full wave rectifier. In full wave rectifier there is having two diodes, and bridge rectifier it is having four diodes. When in full wave rectifier coming the first half cycle, the diode 1 is forward biased and diode is reverse biased. Coming to here, for the first half cycle, the diodes, two diodes, what are those? D1 and D4 are forward biased, same like forward full wave rectifier, and the remaining D2 and D3 are reverse biased. See, in full wave rectifier only two diodes. For the diodes, D1 is forward biased and D2 is reverse biased. Alternatively, in this there is having two diodes are forward biased and two diodes are reverse biased. For the next negative half cycle, the remaining diodes D2 and D3 are forward biased, and D1 and D4 are reverse biased. See, the bridge rectifier also looking like same operation of half wave rectifier. Now coming to here, you will see what are the output voltages of bridge rectifier. It is also looking like same as full wave rectifier. Now we are taking input waveform. This is Vin equals to Vm sin omega t. This is omega t 0, 5, 2, 5 and 3, 5. Now we are observing that what is the output. For the first half cycle we are getting the maximum voltage. What is it? From 0 to 5. For the first half cycle the diode D1 and D4 is forward biased. For the next negative half cycle, which diodes? The next two diodes D2 and D3 are forward biased, the remaining are reverse biased. Like this, here the diode D1 and D4 are forward biased. Like this wise we are getting the output voltage of bridge rectifier. Now we will see the advantage and disadvantage. The advantage of this bridge rectifier is PIV rating, peak inverse voltage. We discussed in half wave rectifier. The PIV rating of diodes or Vm, and only single secondary transformer is required. This is the main advantage of bridge wave rectifier. Now we are going to see what is the disadvantage. See, in the bridge rectifier there is having disadvantages also. The main and major disadvantage of the bridge rectifier is it requires 4 diodes, and the second one is when low DC voltage is required, then the secondary voltage is low and diode drops to 1.4 volt. It becomes it is in significance. And the next one is for low DC output, 2 pulse center tapped rectifier used because the only one diode drop is there. Okay, now we are going to see about ripple factor. Ripple factor. The ripple factor. Why we are using ripple factor means the ripple factor is a thing we are used to measure the purity of DC output of a rectifier. Used to measure the DC purity of DC output of rectifier. For this we are using the ripple factor. Now we are going to the formula of ripple factor. What is the formula? RMS. RMS means root mean square. The RMS value of the AC output voltage, root mean square value of the AC output voltage by the average DC output voltage. See this formula, which is indicating that measuring of the purity of DC output voltage, DC output of the rectifier. See the formula, the ripple factor is RMS, root mean square value of the AC output voltage divided by average DC output voltage. Now what we will get the in equation type, root of output voltage square plus summation n equals to 1 to infinity Vn square. This is the ripple factor equation. And now equals to root of V square RMS minus V out square. This is output voltage. This is V out of DC voltage. This is AC output voltage. Now we get the whole root of Vrms by V out whole square minus 1. This is the formula and the equation of bridge wave rectifier ripple factor. Thanks friends. In next section we will see about water clippers and clamper. Thanks friends.